You know that feeling? You're rushing to check a crucial email, or maybe you're trying to log into your bank account real quick to make sure a transfer actually went through.
Oh, yeah, we've all been there.
Right. So you type in your username, you type in that password you meticulously crafted, you hit enter, fully expecting to see your inbox.
And then
Everything just halts.
Exactly. The screen changes, your phone lights up across the room, and suddenly you're forced to go grab it, unlock it, and punch in a random 6-digit code before a tiny timer runs out.
It's an incredibly familiar friction point for all of us these days. I mean, it breaks your concentration, it interrupts your workflow.
Yeah, it really does.
And if we're being completely honest, it can feel like a massive, unnecessary roadblock when you're in a hurry.
It totally does. It feels like you're being interrogated by your own devices. But today, we're going to completely change how you view that little interruption. We're doing a deep dive into a punchy June 2026 post from Aaron Rose over at tech-reader.blog.
Right, the piece titled, Multi-Factor Authentication in 3 Minutes. That's the one. Now, Aaron's goal with that post was a quick sprint through the basics. But our mission today is to slow way down. We want to really unpack the underlying engineering and, honestly, the psychological shift driving this massive change in digital security.
It's a much-needed conversation, honestly.
Yeah, because the goal here is that by the end of this deep dive, you'll understand the hidden mechanics of multi-factor authentication MFA so well that you'll just never look at those login codes the same way again.
And to set the stage for this, we really have to establish a foundational truth about the current state of the web.
Okay, what's that?
The internet has fundamentally grown up. We are so far removed from the Wild West of the early 2000s.
Oh, for sure. The days of just, like, putting up a basic web page and calling it a day.
Exactly. Because the internet has matured into this massive, mission-critical piece of global infrastructure, our security architecture had to evolve right alongside it. The ecosystem we're defending today, it just doesn't look anything like the one we originally built passwords for.
Right. And before we can really grasp what MFA is doing under the hood, you need to understand exactly why that old password-only system collapsed so spectacularly.
It really was a spectacular collapse.
Yeah. I mean, if we look back 20 years, the model was straightforward. You create an account, you pick a secret word, you log in. It was a linear one-to-one relationship.
It was simple. And, you know, for a very brief window in internet history, it was somewhat sufficient.
Right.
But the reality of today's threat landscape is vastly different. I mean, over the years, billions of usernames and passwords have been siphoned out of various corporate databases through these massive data breaches.
Billions with a B.
Billions. And they aren't just floating around in a vacuum. They've been categorized, indexed, and made readily available for attackers to just download.
Okay, let's unpack this, because this feels like a crucial distinction to make for anyone listening who still thinks hackers are just sitting there guessing their pet's name.
Right, that's not happening anymore.
So if the passwords people are using today are essentially the same types of complex strings they were using years ago, are we saying the passwords themselves became inherently weaker, or did the attackers just figure out how to scale their attacks infinitely?
It's absolutely the scale and the automation. That's the core insight here. Attackers aren't sitting at a keyboard trying to manually guess your password.
They'd be there forever.
Exactly. Getting the password has actually become the easy part of their job. They use sophisticated automated tools, often routed through vast networks of residential proxy servers, just to hide their tracks, to execute what's called credential stuffing.
Credential stuffing.
Yeah. They take those billion stolen passwords and they use scripts to automatically test them across thousands of different websites simultaneously. We're talking millions of times a second.
Wow. So we'd spent all this time stressing over whether our password has, enough special characters, capital letters, or numbers.
Right.
But if an automated botnet is just blasting stolen lists into login portals at lightning speed, having a complex secret word doesn't actually prove you are who you say you are.
Not at all.
It just proves your password was in a database somewhere.
Precisely. And that's exactly why the entire security industry had to pivot. The real challenge of modern digital security isn't keeping the password a secret anymore.
Right, because the secret's out.
Exactly. The challenge is independently verifying that the person typing the password is the legitimate human being who actually owns the account.
Which brings us to the second checkpoint. Since knowing the password no longer proves ownership, systems have to verify your identity through an entirely separate channel.
Yeah, that's the multi-factor.
Right. You enter the password, And the system essentially says, okay, that's the right word, but I still don't trust you.
Yeah.
And it demands that temporary verification code.
And that is where the automated credential stuffing script just hits a brick wall.
It just stops them cold.
Pretty much. The attacker's bot might have pulled your perfectly complex password from a data breach, and the system accepted it. But without that second factor, the attack simply dies on the vine.
Now, I really want to dig into the actual mechanics of this, because for a long time, I just thought of those authenticator apps on your phone as some sort of, like, internet magic.
A lot of people do, honestly.
Right. Because the app generates a 6-digit code, you type it in, and the code changes every 30 seconds. But neither the phone nor the app actually needs an internet connection to generate the right code.
No, they don't.
So how on earth does the website know what 6 digits my phone is looking at if they aren't even talking to each other?
This is honestly one of the most elegant pieces of cryptography we use every single day. It's called a time-based one-time password, or TOTP.
TOTP, got it.
So when you first set up that Authenticator app and you scan that little QR code on your computer screen, what you're actually doing is securely sharing a secret cryptographic key between the website server and your specific phone.
Ah, okay. So they both have the exact same starting ingredient.
Exactly. They both hold that same secret key, and they both have internal clocks just ticking away.
Right.
The algorithm takes that shared secret key, combines it with the current timestamp, and runs a complex mathematical equation that spits out a string of numbers.
And then it just shrinks that down.
Yeah, it truncates that down to the 6 digits you see on your screen. So because the server and your phone have the exact same secret key and the exact same time, they independently arrive at the exact same 6-digit number at the exact same moment.
That is fascinating. It makes me think of an analogy.
Okay, let's hear it.
It's like, okay, imagine two people having the exact same combination lock. They agree on a master blueprint, which is the QR code.
Right.
And they agree on a set of rules that says every 30 seconds, based on the atomic clock, we're going to mathematically rotate the combination. So they never actually have to call each other on the phone to coordinate.
They don't need to communicate at all.
Right. They just check their watches, do the math, and they both know the lock will only open if the dial matches that exact minute's combination. Or it's like a nightclub.
A nightclub.
Yeah. The password gets you to the front door, but the bouncer, which is the MFA, asks to see a VIP wristband that magically changes color every 10 seconds. Even if a thief knows the secret knock, they don't have the wristband.
What's fascinating here is how perfectly that illustrates the severing of the password from the account access. Because the combination or the wristband color is constantly rolling based on time, a stolen password is just useless.
It's totally detached.
Exactly. Aaron Rose's text highlights this explicitly. A stolen password does not equal a stolen account when this mechanism is in place.
Right.
I mean, even if an attacker was literally looking over your shoulder or managed to intersect the code as you typed it, by the time they get back to their keyboard to try and use it, the clock has ticked, the math has changed, and that code is completely worthless.
It's just an incredible defense against automation. But as we move through the landscape of MFA, we start to see that not all of these checkpoints are created equal. The source material outlines a pretty clear hierarchy of MFA methods.
Yes, because in cybersecurity, security is always a spectrum. It's an arms race.
Always.
And the different delivery methods for MFA offer very different levels of protection. You have SMS text messages, you have the TOTP authenticator apps we just discussed.
Right.
And at the highest end, you have physical hardware security keys that plug directly into your USB port or use NFC.
Now, here's where it gets really interesting. Because the tech community is very vocal about preferring authenticator apps and hardware keys while actively pushing companies to abandon SMS text messages entirely.
They are very loud about that, yes.
But wait, if attackers are using automated scripts from massive server farms halfway across the world, why are text messages considered weak? I still have my physical phone in my pocket to receive the text, so the bot is still physically blocked, right?
You'd think so, but you have to look at the underlying infrastructure of how a text message is actually delivered. SMS wasn't built for secure authentication.
What was it built for?
It was built for convenience. It relies on cellular networks, specifically a routing protocol called SS7, which is notoriously flawed and can be intercepted.
Oh, really?
Yeah, but honestly, the much more common threat that everyday people face is something called a SIM swap attack.
A SIM swap.
Yeah.
Is that where they essentially steal your phone number?
Exactly. Highly sophisticated attackers don't actually need to steal your physical phone out of your pocket.
That's reassuring, sort of.
Well, what they do is they just need to trick a customer service rep at your telecom provider. They call up, they pretend to be you, they claim they lost their phone, and they ask the rep to port your phone number over to a new SIM card that the attacker controls.
Wow.
And suddenly your phone just loses service, and the attacker starts receiving all of your SMS two-factor authentication texts directly to their own device.
So they completely bypassed the digital cryptography by just using social engineering on a human employee.
Exactly right.
The automation script doesn't solve the physical problem, but a clever hacker with a phone can just route the texts right to themselves.
Precisely. Which is why security professionals strongly prefer localized physical security.
Like the apps.
Right. With an Authenticator app, the code is generated locally on the physical silicon of your specific device, not transmitted over a hackable telecom network. But even Authenticator apps have a vulnerability.
Uh-oh.
Yeah.
What's the vulnerability?
You, the human.
Of course. It's always us.
Always.
Right, because if I get tricked by a highly convincing phishing email that looks, exactly like my bank, I might unknowingly type my 6-digit TOTP code right into the attacker's fake website, and then they just instantly forward it to the real bank to log in.
Exactly. The human can still be fooled. We can be tricked into handing over the code, and that is why the absolute top tier of the MFA hierarchy is the physical hardware security key.
These are often called, FIDO2 or WebAuthn keys.
That's right. They are actual physical devices you plug into your machine or tap against your phone, and they don't rely on you typing in a code at all.
How do those differ from the Authenticator apps, though? Because, you're still just using a piece of hardware to prove you're there, right?
The major difference is that a hardware key removes the human from the verification process entirely. It uses asymmetric cryptography.
Okay, break that down for me.
So, when you plug it in, your browser talks directly to the key. But crucially, the key also checks the website's digital certificate. The hardware key actually knows what website it's currently on.
Oh, wow.
Yeah. So if you click a phishing link and end up on a site that looks exactly like your bank but has a slightly different URL, maybe a letter is swapped, the hardware key recognizes the mismatch immediately.
And what does it do?
It simply refuses to authenticate. It is physically impossible to be phished because the key won't give up the cryptographic secret to the wrong domain.
That is brilliant. It's like the bouncer at the nightclub isn't just checking your ID. Your ID is interrogating the bouncer to make sure you're at the right club before it hands over any information.
That's a great way to look at it. You completely eliminate the human tendency to fall for a good disguise.
It just breaks the attack chain completely.
Yeah.
And I think this brings us to the underlying philosophy of this entire shift in the industry. Why has this tiered multi-factor approach become the absolute mandatory standard everywhere, across corporate VPNs, cloud services, personal banking?
Yeah, Aaron Rose points out what they call a common mistake in how people view this whole thing.
Right. People see the MFA prompt and they think, my bank is forcing me to do this because they think the password I created is too weak or too easy to guess.
Exactly. Users take it personally. They feel insulted.
Yeah.
But the reality is far more pragmatic. The systems aren't judging your ability to create a complex string of characters. They are operating on a completely different paradigm now. Modern security architecture operates on the fundamental assumption that your password already has been, or inevitably will be, compromised.
So what does this all mean? It represents a massive departure from the old way we thought about security. For decades, security was a castle and moat model.
Very much so.
You build a massive wall like your firewall, your complex passwords,
Yeah.
and you assume that anyone who makes it inside the wall is a trusted user. But the data breaches prove that eventually someone is going to drain the moat.
Right.
Someone is going to get a copy of the key. It's honestly exactly like wearing a seatbelt. It's not that you don't trust the brakes on your car, which will be your password. It's that you accept we live in a world where accidents or data breaches are just inevitable.
If we connect this to the bigger picture, what we're talking about is the transition to a zero trust architecture.
Zero trust.
Yeah, and zero trust literally means what it says. The system trusts absolutely no one, whether they are outside the network trying to get in or already inside. In a zero trust model, just presenting a valid password doesn't earn you trust. The system demands continuous contextual verification.
So it's constantly checking you.
Exactly.
Yeah.
It wants to know, is this the right password? Yes. But is it coming from a recognized device? Is it happening at a normal time of day? And most importantly, can the user physically prove their presence with an independent factor?
It's treating every single login attempt as inherently hostile until proven otherwise.
That's exactly it.
It's not about building a higher wall to prevent breaches. It's about building internal checkpoints to mitigate the damage when the wall inevitably fails. Adding that distinct physical layer of proof is arguably the most effective security improvement the industry has made in the last decade.
And the beauty of it is that it embraces human vulnerability.
Yeah.
We know humans reuse passwords. We know humans fall for phishing emails. It happens. Rather than trying to train humanity to be flawless, which is impossible, we implement an engineering solution that simply catches the error.
It truly is an elegant fix to a systemic problem. So to wrap up our deep dive today, we started 20 years ago when a simple password was enough to get you through the front door.
Simpler times.
Definitely. We watched as billions of credentials were stolen, indexed, and weaponized by automated botnets running credential stuffing attacks at just unimaginable speeds. We unpacked the cryptography of time-based rolling codes and the ultimate phishing protection of physical hardware keys.
It's been quite the journey.
And finally, we explored the psychological shift to zero trust, that pragmatic acceptance that passwords will be breached. Hopefully, the next time your phone buzzes and asks you to approve a login, you won't see it as a nuisance. You'll see the incredibly complex mathematical handshake happening in the background, keeping your digital life secure against a relentless tide of automation.
Absolutely. And while this current architecture is incredibly effective, exploring this topic always leaves me thinking about the next phase of the arms race.
Oh boy, where are we heading next?
Well, think about it. We instituted the second checkpoint because automated tools learn to rapidly test stolen text. But technology never stops evolving.
Right.
This raises a really important question for all of us as we look to the horizon. As artificial intelligence becomes deeply integrated into these attack vectors, generating real-time, flawless deepfakes of our voices or our faces.
Oh, wow.
How long will it be until automation finds a way to bypass our current biometric and physical checkpoints? And when that day arrives, what will our third checkpoint even look like?
Wow. That is a chilling thought to end on. The cat and mouse game truly never ends. The board just gets more complicated. But for now, you can rest easy knowing exactly how your current defenses are holding the line. Thank you so much for joining us on this deep dive into the hidden mechanics of multi-factor authentication. Keep your keys close, trust the math, and as always, stay curious.